Hello, in the last video we have learned about the positive clamper circuit, and in this video we will see what is the negative clamper circuit and its function. As said earlier, the negative clamper circuit lowers the applied signal. Circuit is like this. The diode is inverted. Resistance is here, and here is the output VO. This is V in. This is our capacitor, this is the diode and the resistor. Now, like we did in positive clamper circuit, here we also do analysis of the circuit at different time ranges. Let us here take the input as Vm sin omega t again. In this waveform, from 0 to t by 2 the signal is positive, and from t by 2 to t by 4 it is negative. First, from 0 to t by 4 the circuit was initially not connected, hence the capacitor voltage was 0. But if we take a look at the equivalent circuit, we can see that this diode's P side is connected to the positive side of the signal, and the negative part is connected to the N side, that is the diode is in forward bias, and hence we can replace the diode with a short circuit. Now this will short the resistor here also, so our equivalent circuit will be this. Now here there is no discharging element, so the input signal will charge the diode in this direction now, so it will be plus and minus, and it will be charged up to the peak value of Vm in no time, because here again the tau is Rc and R value is 0. So in this time range from 0 to t by 4 Vc will become Vm and Vo will be 0, because the RL value is 0 and hence Vo will be 0. Next, from t by 4 to t by 2 the capacitor will now act as a voltage source. Now the diode seems to be in forward bias, but we have to determine this. Here is a Vm, here is V in. Now put KVL law in this mesh, and we will get V in minus Vm minus Vd equals to 0. That is Vd is V in minus Vm. Now from the circuit we can say that the diode will be in forward bias if Vd is greater than 0, because in that case the polarity of the diode will not change, so V in should be greater than Vm. Now again here the maximum value of V in is Vm, so it can't be greater than Vm, and since this is the condition for the diode to be in forward bias and it doesn't hold, so the diode will never be in forward bias after t by 4. Equivalent circuit will be this. Here is VO, this is VM, and this is V in. So applying KVL law, VO will be V in minus VM. Now we will deduce various values of VO at different time instances and use them to draw the output graph. So VO at t by 2 will be Vm into sine omega t by 2 minus 1, that is Vm sine pi minus 1. Sine pi is 0, so this is minus Vm. VO at 3t by 4 is Vm sine 3 pi by 2 minus 1. Sine 3 pi by 2 is minus 1, so this is minus 2 Vm. Next, VO at t is Vm sine omega t minus 1. This is sine 2 pi, and sine 2 pi is 0, so again minus Vm. VO at 5t by 4, this is Vm sine 5 pi by 2 minus 1. This is minus 1, okay. Sine 5 pi by 2 is 1, so this value will be 0. VO at 3t upon 2 will be Vm sine 3 pi minus 1. Sine 3 pi is 0, so minus Vm. VO at 7t upon 4, Vm sine 7 pi upon 2 minus 1, and this will be minus 2 Vm. And VO at 2t will be Vm sine 4 pi minus 1, that will be minus Vm. From these values we can say that after t by 4 the value of VO has never been positive, that is, after that instant the signal has been negatively clamped. Now these values will be helpful for drawing the graph, so let us draw the graph now. This side we are taking t, and this side VO. Suppose this is our minus Vm and this is minus 2 Vm. We are dividing the time axis in duration of t by 4. From 0 to t by 4 VO was 0, then it was minus Vm, then minus 2 Vm, then minus Vm, then 0, minus Vm, minus 2 Vm, minus Vm, and so on. So after this instant our input was this, so we can say here it was 0 and this is minus Vm. So we can say the signal has the same shape, but the only difference is the DC level has been shifted from 0 to minus Vm, that is towards the negative side, and hence this circuit is a negative clamper circuit. So thanks for watching the video again. If you find this video helpful, then like and do share with your friends, and also subscribe the channel for more videos. Thank you.